Hi everyone, welcome to Tableau Desktop, the advanced session. This is the last session of the Tableau Desktop Data Analytics Visualization series. So in this session, we will try to go through into some topics that we didn't cover in the last two sessions of the Tableau Desktop. For example, going through into the advanced table calculation, some of the built-in table calculation available in Tableau Desktop without needing any writing any specific expressions, or jumping briefly into some of the aspect of how we could just control the level of the detail that we have in our expression, which is called the level of detail expressions in the Tableau Desktop, and jump into some examples providing some different chart types that need some tricks to create in Tableau Desktop, which might not be available right away. For example, creating the donut charts, waterfall charts, or some more interactive charts that could be, for example, be used by creating some animation from those charts. So that's will be provided in this session. And at the end, some again, some techniques that we didn't cover about customizing the dashboards, for example, adding some sliders, navigation button to, for example, navigate through different sheets or visualization in your dashboard, and some examples of the dashboards that are created with Tableau Desktop. And at the end, the homework that you can just go through it for receiving the certificate of completion of this session at the end. Similar to what we had for the last 2 weeks of the Tableau Desktop session, the prerequisites are installing the Tableau Desktop software. If you have it, you don't need to install or download it again. But if you don't have the Tableau Desktop, please use this link to download and install it in your computer. For the sake of this workshop, the trial version works fine, but Clemson has a license, a student license that could work up to 1 year. If you sign up in Tableau with your Clemson username, you would receive a license that you can just use it for the installation of Tableau Desktop. And similar to what we had before, download the COVID-19 data set for the state of South Carolina from this link. If you have it from the previous sessions, you don't need to download it again. But if you don't have that, please download this desktop that you would use for creating the visualization or going through the materials throughout this workshop. So I would wait a couple of just a minute to make sure that everybody has the software installed and also be able to download the data set. And after that, we will jump into the first session of this workshop about the advanced table calculations. Please let me know if you have any question or comment. Just you can just put it in the chat, or just you can just unmute yourself and ask your question. By the way, I would just put the link for downloading the data set in the chat as well. I believe I put that, yeah. So you can just download it from the chat. But let me know if there's any error difficulty or if you were not able to download the data set. Okay, so with that, we will jump into first section of this workshop, which is about the advanced table calculations. Usually the table calculations in Tableau Desktop rely on two types of fields, which is called the addressing and partitioning fields. And when we say the partitioning fields that define the scope, they could just break up the view into multiple partitions or subviews. And then a table calculation is applied to the marks within each partition that we have in the subviews of our visualization. The addressing fields define the direction, and when we say the direction, that just could be just some moving calculation, like for example, moving averages or moving sums or some other calculations that we had in the previous week as well. There are several ways to define these calculation in Tableau Desktop based on the way that you want to control your calculations. There are some built-in features which is called the quick table calculation in Tableau Desktop that you can just use it right away for creating, for example, moving averages, moving sums, or other type of the calculation. So you don't need to write any expression in the Tableau Desktop to be able to calculate your new field. Or similar to what we had in the previous weeks, that we wrote some expressions in order to calculate some new fields. You can just use the add table calculations. So you are able to add some expressions and be able to calculate new fields or new columns in your data set. The first example here that we want to create here for calculating the percentage difference from a reference date that we have. And in order to calculate that percentage difference from a reference, first we need to create a parameter which is called the enter reference date, and we could just choose a reference, for example, first day of June of 2020, and then be able to calculate the percentage change. So we'll go back to what we had before. So we will jump into the Tableau, and similar to what we had in the previous weeks, you can just open the SC counties data set that we had and go to the sheet one. And we learned how to create the parameter last week. So could create a new parameter as inter-reference date. And because it's a reference date, so of course the data type is date. And we could create that here and put the first day of June of 2020 here. In this way, our parameter would be fixed and only have that value. But if you want to just give the user ability to change the reference date, you can just use a list or even create a range. But here, I'm going to use a single value for the reference date that I have that I want to use for calculating the percentage difference. So with that, I would have this reference date here. And now I need to create a new field, which is called the sum of the cases that are closed on the reference date that I have. The purpose here is that find because I want to just return the values that are close to my reference date, and for example, ignore before or after the reference date that I have. So I could just create a new calculated field, which I'm going to call it this. And the formula is shown here. So I'm going to type that. We are going to use the window max here, which would return the maximum in a specified window, similar to moving averages or moving sum or moving minimum. The window max function would do the maximum aggregation on a window that we have for example, several time span or the date that we have. It would just do the maximum, moving maximum over our data. So the expression is going to write it, and then after that, I'm going to explain the expression that we have. So I'm going to make it a little bit bigger. So I want to just do the summation of the cases that are close to my reference date. So I'm using the window maximum function, which as I said, it just take the moving maximum over a range of the data that I define. So the first expression here, this if statement here, tells Tableau that if the maximum of this date value is equal to the reference date in this range that I have from the first data point to the last data point is equal to the reference date, return the sum of the cases, otherwise return the null. So it's just like that I'm ignoring the values that are before the reference date. So that expression would just return the null for any date that is before my reference date that I have. Otherwise, it just return the summation of the cases. And this window maximum, again, find the moving maximum of this sum of the cases in this range of the first and the last data points that I have. I'm going to create that. And for calculating the percentage difference, we create another table calculation here. And the formula is this, so I'm going to describe this formula. So here I'm going to just do the summation for all the cases and subtract the summation that were close on the reference date, and then just divided by those summation of the close reference date. That just tells me that how far I'm from the reference date that I have. And then I would be able to visualize this with that, and similar to what we had before, we could, for example, break it down to different counties, for example, or even could just, for example, put some colors or not this, just remove only the counties. And you see that here, this is the first day of the June that I defined as the reference. And everything behind that, it just ignored here, but I'm just calculated the percentage difference from that specific date that I had here. But I just chose a fixed date here in my parameter. But if you want to just give the user ability to be able to change that, you can just have a list or even a range of the date for your reference, and even show the parameter and give the user ability to choose the reference date itself by themselves. For the visualization, if you're asking that I just put the date in the columns, I just choose the continuous day here. But if you're getting all null values, there might be some maybe problem in the way in the expressions that we used that you used for the sum cases for the find the sum cases close on the reference date, or this percentage difference. So I'm going to, if it's possible, to double check the expression for the sum cases close, and you can just copy paste that, or also use this one for the actual percentage difference that we have. So it should not return all the null values. Can you just double check that to see if the expression that you have for those new fields that you calculated? The data source, I just use the one, the sc-counties.csv. You can just open that right away and be able to just calculate these two fields and be able to create this visualization. Okay. The next one, the next calculation that we are going to do on our data is called the difference from calculation. In order to calculate the difference of data from a certain point in the previous example, we could just use the difference from calculation. Okay, so did you use that? Because I didn't, let me try again in a new Tableau, the blank one. Anybody else has this problem or just these two cases? So let me open Tableau again. So I just use this SC counties. Click and open, go to the sheet. I just created a parameter which is called the enter reference date. It's a date type and it's the first day of June, or you can just choose whatever you want in the 2020 before the October. That doesn't matter really. and create this parameter and be able to make sure that the data type is date and the reference date is on the first day of June 2020. And click on OK and create a new calculated field, which is called the sum cases reference date, and I'm just using the formula that I put in the chat. Okay, and create another one. Again, I'm going to use this one. I just call it the percentage difference. Click OK, and for the visualization, I just put this one into the rows and this one to the, and I just choose the day here, and I'm able to see this. And I just, it's just similar to what we had last week. I just break it down. Okay, so if it's, yes, for the visualization, as I believe we just went through that previous week, you need to choose the continuous date. So don't choose this day. The continuous one is here. Oh, that happens. Yeah, that happens. Any other question? Any other problem? I believe we just went through that in the previous weeks. The first year, quarter, months, day are the discontinuous ones, and these ones are the continuous. You just assume that your data is continuous. And for the percentage difference, you can just right click here, create calculated field, similar to what we had last week, and just copy and paste the formula here and choose whatever name that you want, percentage difference or whatever that you can just use for visualization. Any other question or problem? Okay, I'm going to that. Okay, well, the next one is called the difference from calculation. For example, let's say you want to, instead of calculating the percentage difference from reference date, similar to what we had in the previous section in this workshop, you want to just, for example, calculate the daily, weekly, monthly, or other changes from your data. Something like taking the derivatives of your data, similar to that. You want to just, for example, store the data I plus 1 minus I. So you want to just see how it's changed in a given range. For example, 1 data point later, 7 data points later, which we call it, for example, weekly or whatever. So the difference from calculations gives you ability to take, calculate that changes, for example, in a given range, 1 data point or other range that you define for calculating that difference from. That's possible with the lookup tables and finding for example, finding the data points that it is just one data point behind, or 7 data point behind, or 10, or whatever that you want to define. So we want to create a new calculated field, which I'm going to call it daily cases, because here the cases that we have here is just the number of cases, totally cumulative number of cases until that day. But another interesting information might be to find out what's the number of new cases in each day. So that's possible to calculate that with that lookup table to find, for example, some data point behind, or in some other ranges that you want to define. So I'm going to create a new calculated field and call it daily cases. And that's the expression here for daily cases. So basically, it just tells that I want to just subtract the cases from one data point behind that to find the daily cases. Because if it's a cumulative number of cases, the new cases in that day would be just the subtraction of that cases from the previous data point. But if you, for example, if you want to just find the weekly cases, you can just put -7, or if you want to just do the monthly cases, new cases, you can just find, put it 30, or what other range that you want to define here. And this lookup would just find that data point, which is one behind this one here I have. And I'm able to visualize that. And this would give me, let's filter some of the counties for better visualization. Say I want to choose this. Yes. Now, the last thing that we are going to go through that here is, here we have two different plots in a single view, but it's also possible to overlay them together, overlay these two graphs together. If you want to just do it simply, you can just go to the second one here, the daily cases, and choose the dual axis. It would just overlay these two plots together. And the left one is the percentage difference, and the right axis is the daily cases. And even to how I plot that, I'm going to remove that. I just put the daily cases into the rows, and now I have two plots here. And in order to combine them, here go to the daily cases and choose the dual axis. That would combine or overlay these two plots together. Now you have two different axes here. And even to more customize that, both of them are in the line plot type. Here you have ability to choose attributes of your different plots here. The first one is the percentage difference, would change this one for the percentage difference, and this one daily cases would change the attributes for the daily cases. The first attribute is that I can just change the plot type that I have. For example, instead of using the line, I'm able to use, for example, the bar charts for that. So that's possible to customize it a little bit, and even use any other type of the shapes or chart types that you want to use. So that would give us a little bit more customization of, first of all, in order to overlay these two plots together. And even, for example, if I back to the bar charts, you see that my bar charts mask these lines in some areas. I am able to give some opacity, decrease the opacity, for example, to 50%. And now it just have a better visualization. I'm able to see those lines along these bar charts that I have for the daily cases as well. Any question regarding creating the daily cases or overlaying these two charts or plots together?
And if I wanted the lines to be in front of the bars, then I would just need to put the daily cases before the difference.
Yes, something like this. Yeah. Now, if I bring back opacity, it would be just like this. Yeah.
Okay, thank you.
Yeah. We just can just change the sequence of the daily cases or differences by just dragging and dropping, something like this. Yeah. Any other questions that you might have here, or any other comments, or going through the last section of using the advanced table calculations? Um, Instead of using the one the expressions that we created by using new calculated fields in, for example, creating new fields or columns in our data, Tableau has some built-in table calculations that you can just use it right away without writing any expression. So in order to create those built-in, use those built-in, I'm going to create a new sheet here. And for example, simply put the date and cases here that I have, and put the, for example, county, and color, even just filter some of these 4 counties that I have. And in order to do those table calculation, I can go to the cases and click on the add table calculation. And you see that there are some different calculation type already available in Tableau. Built in, you don't need to write any expression. For example, similar to what we did with that lookup expression, you can just calculate the difference from, which is just calculates the new daily cases, or percentage difference. Or for example, doing some moving calculation, taking the average, for example, previous We did all those calculations, for example, calculating the difference from, percentage difference from, or moving calculations. But here, without needing any expression, you are able to calculate any built-in, any common fields by just using the built-in functions that are available in Tableau Desktop. So that's one advantage, that you can just use, calculate this if your calculation comes to one of these categories, for example, difference, percentage difference, some running total or moving calculation, or even you want to just calculate the rank, which means that you just rank your data points based on, for example, maximum, minimum, or other conditions that you put here. So you can just use that right away without needing to write any expression. But the advantage of the expression is that it might look a little bit difficult, but you have more control on what you want to write or what you want to calculate by combining some of the functions that are available in Tableau. So that's also one feature of using the built-in calculation in Tableau for example, going through the difference from, percentage, or moving calculation that are available. So before jumping into the next section, any question, any comment about using the built-in calculation functions in Tableau? Okay, all right. So let's jump to the next section. Those are available for all the fields, but the things that are limited is that the expression, the things that you want to calculate. For example, if it's moving calculation, we would just create. It's good, it's useful for if your calculation fits in one of those categories. For example, calculating the difference from, moving calculation, percentage difference from. But if you want to just customize, or for example, calculate an expression that might not be available in one of those categories, so you need to use the write some expression and be able to calculate those customized fields. But if your calculation fits in one of those categories, it's really useful to use the built-in functions without writing any specific or explicit expression here. Any other question, comment about uh, the advanced table calculation that we had? Okay. The next section of this workshop is about how we could control the level of detail in or granularity of the calculations that we are doing in Tableau, which is called the level of detail expressions in Tableau. The level of detail expression, that usually known as the LOD, gives you some ability to control the compute values that you are calculating from your fields, to what level of detail that you want to do those calculations, and also at what level you want to visualize those expressions. These all the expressions that we have in Tableau, they can be performed at a more granular level, which are called the include, or less granular level, which are called the exclude, or entirely independent level, which are called the fixed. So we are going to go through these three different level of the granularity that are available in Tableau Desktop and see how what they mean and how we could use them. For example, let's say you want to calculate the cases per county that you have. So I'm going to create a new field. It's called the cases per county and write this expression and then include and then I'm going to describe the expression here. So here I'm just telling the Tableau that take account the difference between the counties for when you want to average the cases or calculate the average the cases. Let's say if I just write simply, instead of that, if I just write simply the average cases without including the county. It doesn't care, the Tableau desktop won't care, it would just calculate all the averages of the cases in all the counties. It's like something like taking the average of the cases in the state of South Carolina, regardless of looking at the counties. But when I'm telling Tableau that include the county, it would just consider the county uh, as a new granularity that I want to just consider for averaging the cases. So it would just calculate the averages in different counties separately. So that's the meaning of uh, including the county. So that's the meaning of using the level of detail expression, which is called the include, to include any, for example, field or variables that you want Tableau to consider when calculating your field here. And now let's see if we visualize that. Similar to, pretty much similar to what we had before, but we did that, we just, Tableau also would include, if you just, instead of writing the include county and writing, for example, simply average cases without expressing explicitly shows the level of the granularity as the include, it would just do that automatically when you just want to break it down by using the marks for you. But by choosing that, you explicitly calculate, or you are able to store those data. Not only shows the visualization, but you are able to store that data and be able, for example, to combine with some of the other fields that you want to do the calculations. So that's the advantage of Express, showing the level of the granularity explicitly. But for example, in this example, you don't have to write it explicitly, because if you just simply wrote the average cases and be able to, if you want to just break it down in different counties, you want to just, for the sake of the visualization, you can just put the county in the marks and that would just break it down in different counties for you automatically. The sliced cases is the one that we used last week, that we sliced the cases at certain uh, dates at the first day of the month. So if you just see that in here, it just used the sliced cases. It's built upon based on the material that we have for the previous week. If you remember, we calculate the sliced cases in order to slice the cases at the first day of each month. And we visualized the slice cases by using a map across different counties of the South Carolina. And even we created a slider that we're able to change that a slice date for just seeing the cases across different counties in different first day of the month. So that's the one that we used in the previous weeks. As I said, we had two other type of the level of the detail expression, which are called the fixed and exclude. The fixed level of detail expression compute a value using the specified dimension, but without reference to the dimension in the view. So we would just, for example, fix the counties, and then it would just, for example, if let's say instead of the include county and then taking the average of the cases, let's say if I change the cases, change the include to the fixed, and how would that would change the visualization that we have. I could edit the cases per county, and instead of the include, I'm able to change that to fixed. Yeah. So you see that it just pretty much constant. So it means that uh, it would just fix my value and then calculate the averages, which obviously we don't want to do it here, but it would just fix the county. So it just doesn't change that. So that's the reason why you just take the, for example, the first data points in your table and then just calculate the average of that. So it would just, it doesn't, that's the reason why it doesn't change with the dates here. It's just a flat line for each county that we have. And for the exclude level of detail expression, you just tell the Tableau desktop to exclude this dimension from the view of the detail that we have from the calculation that we are trying to do. The exclude level of detail expression is useful for calculating, for example, the percent of total or difference from the overall average scenarios, which they are comparable to, for example, totals or the reference lines that we saw before. And the exclude level of detail expression cannot be used in the row level expressions, which means that if you have, for example, a single row, if you want to do, for example, some calculations on some rows in your data, and there is no dimension to omit, you cannot use the exclude. So that's the one. The exclude generally would just exclude that dimension that you give it from your expression, from your calculating the expression that you are trying to calculate. So let's also change that to exclude. How that would change, and as we expected, it would just exclude the county. So it just take the average over uh, all the counties that we had. So it would just exclude that county dimension from the calculation. And even I just break it down into different counties, but it doesn't show me any difference because everything is calculated with just a single one. It doesn't matter between different counties. So the counties is excluded from the calculation. So that's the reason why we see a single plot here instead of the breakdown of different counties, because the counties is excluded from our calculation, and that's what we expect in the visualization, to don't see any variance between the different counties because it's excluded from the calculation that we had. And the last thing that we have here for the level of detail expression are called the table scope. Also, it's possible to define a level of detail expression at the table level without using any of the scoping keywords like the include, exclude, or fixed. For example, the following expression returns the minimum or earliest date for the entire table, which is equal to, for example, if we fixed and just return the minimum value. But we just use that. It doesn't have to be to these brackets here. So you can just use the first one. But there are some possibility to use these brackets and, for example, fix or include or have some other level of the granularity on our data. But if you want to just use it simply, you don't have to put these brackets behind or after your expression. With that, before jumping into, so I'm going to put this back to include. And before jumping into the next section about the advanced chart types, any question, any comment about level of detail expression?
I'm sorry, I missed the detail that you just mentioned about the curly brackets. You said that we could either include them or not, and it would be the same thing. Is that
Uh,
is or
yes, yeah. For
okay?
example, putting this way would just be equal to the fixed one. So, yeah.
Okay.
Yes, yeah. Table is scoped. Yeah, it's just the same one as what we had for the fixed. Any other question, any other comment about level of detail expression before jumping to the next section about the advanced chart types? Okay. We created different charts in the last 2 weeks of using the Tableau desktop. We just used most of the time we used the lines, simply the lines that we had, or even we just had a few maps for our visualization. And also we saw that we could just use, for example, the bar charts or area charts or any other default charts or plots that are available in Tableau. But sometimes creating some more interactive visualization or some customized charts or plots need some more tricks in order to create those charts. So here we are going to go through some customized or advanced chart types that might be useful for the visualization. And the first one is the motion chart. It's like the animated chart that just, for example, show your data animated here. Just see the example here. It's just animated for these cases versus the date. These motion charts are really useful for showing the time dependency or time series data visualization interactively or in animation. So we could just create, let's simply create a new sheet and put the cases and dates in the day granularity and just again break it down in different counties. And in order to make the motion chart is all you need to do is uh, drag and drop this date to the pages and choose day here. I just dragged and dropped the date to the pages. And because I'm doing the visualization with the day, here also I choose the day, the second day here, which is the continuous one here. And change the mark type from here from the mark type from the automatic to circle. Here I have. And now I would see that it would just run here, but let's just break it back. Just stop it here. And also I'm just going to, because I want to just create a line, not just moving a circle here. So I'm able to just show the history. Let's see. I want to just show the history for all. And here for the show, I just use the both. So that would do the trick and just shows the lines.
Hello.
Hi.
How do we put that? I mean that line. I was shy a bit.
I'll just remove it here again. I'm just going to put it automatic. Okay, it's just a simple chart that we had even previous week. The first thing that you need to do for creating that motion chart is drag and drop the date into the page and change it to the day here and change the mark to circle from automatic to circle. Go to the check mark the show history and go to the show history, choose the all, and for the show, choose the both.
I don't have that. The highlighter. I need to mark the highlighter.
Which highlighter you mean?
Where I mean show history there. I don't have that one in my right hand sidebar.
Do you see this show history here?
I don't have that. Oh, I've seen it. I've seen it. Okay, it's on top.
Just choose the all, and for the show also choose the both marks and trails. And then that would just do the trick and even just see the animation that just creates that plot for us. Or even if you just
Click to play the animation.
Sorry, what?
Where should we click to play the animation?
Here, you can just in this triangle here, it would just moves automatically. Yeah, that might be on the different location on the top, but it as long as you have this date in the page, so that should just show up here. But if it doesn't show up at all, that might be because you didn't drag and drop the date into the pages. Make sure that you have this date in the pages, and then you should be able to see this. Any other question about this, creating this motion chart? Okay. So the next thing is called the bump chart. Basically, we can see the ranks of the data points that we have. So that's the point of creating a bump chart. It's called the bump because you see that, for example, we have some bumps, and it just visualize that how the rank of the data points are changed. For example, here I'm visualizing the rank of the cases over time. And here I see that, for example, the number of the cases in the Anderson County was lowest one here, uh, uh, was the highest one. And after that, the Greenville County take the first place, and the Oconee County has the rank of 4, which means that has the lowest number of the cases. So the Greenville County, for example, here has the highest number of the cases among these different counties. So that's the reason why we see it in the rank of 1. So you just rank it in the ascending or descending order. It's just up to you. You can just change that. And it's called the bump because that might just this rank or the places of the first highest number of the cases over these counties might just change, or the second place or the third place or fourth place might change over time. So that's the reason why it's called the bump chart. But it's just simply a line chart that is just visualized in this way. So as I said, it's just a line chart that is managed to show the difference of cases between each county, and it just gives us more clear picture of what's the rank of, for example, different data points that we have, for example, over time. So here, the one that we want to use for the ranking is cases, and the dimension for break it down is the county. So in order to create a rank, we could just create a new calculated field and call it rank, and use the rank function for calculating average of cases. I'm going to open a new sheet and put the ranks into the and break it down between different counties, and just filter, for example, those 4 counties for better visualization. We just take the rank over all those counties. So that's the reason why we see that, for example, the rank is it does not take even if you filter, it just doesn't take just those 4 counties. It just take over the rank all over the counties. Also, there is another way that we could calculate this rank by using the built-in functionalities here. If I just drag and drop the cases and go to the add table calculation and choose rank, and I'm able to just choose the ascending or descending order, and I'm able to specify the dimension that I want to use for the visualization. Here, I want to just break it down. I will just take the rank over the counties. So that's that, and I'm able to reproduce that visualization that we have here. That's called the rank for just a bomb chart that just takes it, visualize that what's the place of each, for example, each category over another dimension, for example, date or any other dimension. It just visualize the rank or the first top four or whatever that you have in your visualization. Any question about this, creating this bomb chart? Uh, Here I just drag and drop the data and cases, and here I just click on the table calculation, add table calculation. The calculation type was rank. It's in the descending order, and the specified dimension is called the county. So it would just create that. Let me do it again by just removing that. I'm going to put the cases here. So that's the case. So that's a simple one that we have. Here I have the add table calculation. We saw that in the previous section. And here in the calculation type, I'm choosing rank, and a specified dimension instead of day of date, I'm choosing the county. That would do the trick, and it would just, the final visualization would look like this. Yes, you need to specify the dimension for the ranking, because the Tableau needs to know how to rank your data based on what? Based on what to rank. You know what I mean? Even if I don't want to use that, I just calculated the rank here, but it just showed me this. That's because still I don't have the correct dimension here. So I need to choose the counties. Again, I would just see that. It would be the same thing. It's just up to you. You want to use the rank formula that we used here, rank of the average of the cases, and again specify a specific dimension that you want to rank as the county. By default, it would just take the day of dates, but that's not correct. You want to just specify to Tableau that you want to take the rank over the county. You would just see this, or if you prefer, you can just remove this and just simply drag and drop the cases here, go to the add table calculation, rank, and a specify dimension again for the county here. That would just do the trick again. We would have the same chart here. It's up to you. You can just use both. Any other question regarding the bomb chart or the animation chart before jumping into the donut chart? Uh, by default, Tableau Desktop has a pie chart, but the donut chart is useful when you exclude some unused space from at the middle of your pie chart, because that gives you more space if you want to just put some other information, for example, type some information at the middle, which is just this blank space at the middle. But let's say if it was a pie chart, you have all these colors up to the middle of this circle, but that's something like the unused space. You don't actually use that space, and also the donut chart might just be enough for the visualization that we have here. So that's the reason why we want to just create a donut chart, but by default, there is no donut chart right away available in Tableau. So we need to just do some trick to make it work in the Tableau desktop. In order to create that donut chart, let's open a new sheet and put the cases here and counties here, and just choose the pie chart. And let's, in order to have a better visualization, let's confine our and I'm able to change the size of that. And I'm able to just specify the size of that, and even I'm able to show so again, maybe I'm just going to put another county here and choose the label as well. Okay, so that's the pretty basic pie chart that you can just create in Tableau. In order to create another pie
Hello.
chart. Hi.
Hello.
Hi.
Why my pie chart has not shifted? It's still at the edge.
Did you choose the entire view?
Entire, not standard.
No, just choose the entire view.
Okay, fine.
Yeah, and in order to change the size, you can just go to the size and change that.
It is occupied all of my workspace. Okay, fine.
Yes, you can just change the size of your pie chart. So that's a pretty standard pie chart that you should be able to create that.
And labeling the counties.
Go to the label, show the label marks, and put another drag and drop another county here, and just click on the label. The label, something like this. I would just show the label of the counties for you.
Okay, fine.
Yeah. Any other question or difficulty to create this pie chart? Okay. So to create a dual axis for the pie chart, drag and drop the depths twice from the rows twice here. And then instead of using the sum, just choosing the minimum here. For example, I'm going to choose minimum. And make sure that you are choosing the second pie chart here, which is shown as the mean depths 2. And remove any measure or dimension out of it. For example, I have the county, so I'm going to remove that, remove this. And also you can just reduce the size, for example, a little bit here. And then on the second pie chart, I'm going to make it a dual axis. Sorry, I'm not sure why it doesn't show that. Let's just drag all of this out. Okay, again, put the cases and the county in the column. Just change it to the bar chart. Then we'll just go to the entire view here. Put the counties in the filter and choose, for example, counties that I have. Pickens. And for just the visualization, I'm going to show the label here. And I'm going to drag and drop. Put that to the minimum. And again, put another depth here. Put that to minimum. And drag and drop these two guys from each other. Yes, so make sure that you just remove all of things and you just keep this as slice. So that's just do the trick and go to back to that and just do something like this. I can just make it a little bit bigger. I'm just going to make both of them a little bit bigger, possibly something like this. And I'm going to change the color of this to white. So that would create my donut chart here. So basically for the second, this mean devs to drag or remove, drag out or remove everything and just keep these slices here. And then maybe you just reduce the size of the second one a little bit, just up to you. You can just, for example, have a thin donut chart or thick donut chart and make sure you change the color to white. And that would just do the trick and create the donut chart for you. Any question, any comments regarding creating this donut chart? That's a trick to create, actually overlay two different pie charts together and drag out everything and just change the color of the second one to white. And that would just do the trick to just create a donut chart here out of a pie chart available in Tableau. The last one that we are going to create here is called the waterfall chart. A waterfall chart, same as its name, it's analogous to orientation and flow. It just shows you the orientation and flow of the data. Here, we just plotted the moving averages of the cases over time. So you can just visualize the cases over time. And the waterfall charts are used to analyze the cumulative effect of a measure. For example, let's say we are trying to visualize the cases and we want to see how these cases are, for example, changed over time in some ranges of the dates that we have. It's increased or decreased as a whole. So that's the reason why we could just use the waterfall chart. And as I said, it's again similar to what we had for the donut chart. The waterfall chart is a derivative of a line chart. So it means that we are tweaking the line chart to create a waterfall chart for that. So let's create a new sheet here. And again, simply put date. It says here. And we're aggregating by using the average, for example, over all the counties. And I'm going to create a negative, create a new, calculate new calculated field. And I'm going to call it neg. It says, and then I'm just going to put neg cases here and change it to size and use, instead of sum, use the median. And instead of that, I'm going to stop day. That might be better. Day. So yes. And also again, I'm going to put the cases here, change this to color, or even I'm going to change my color, for example, from this. And that's the reason why I see it as a continuous one, is that because I'm just using on the continuous data that I have originally, and I don't work with the dates that we used, the date total that we just created last week for the moving averages. And the moving averages was something like that. We just skipped, for example, 7 days, 10 days, or 14 days for the biweekly ones. So that would just break down your data points into different discrete points. And that's the reason why you can see this separated waterfalls here. And that's the reason why I see that as a just a continuous one. But you see that the thickness of this line chart is changed over time. And when it's just increased, the thickness was just had the maximum at the beginning, because I just put the negative of the cases. But if I just, let's say, if I just change that negative to the positive, it would just make it opposite, because at the beginning I have the less cases, but at the end I have the maximum of the cases at the end of this date. So that would just change the thickness for that. So if you want to just do the same, see the same thing as is it's created here for seeing it's as a discrete points, for to have it as a discrete ones, it's possible to just use that date total for the moving averages that we have in the previous week. And if you want to just see it right away, there is a link that's could reproduce all of this visualization. I'm going to put it in the chat that you can just download the workbook for reproducing all of this visualization, which I'm going to download here and open it. See this waterfall chart here that is created for for that date total that we had. So here, instead of the continuous date that I had, I just used the date total for the moving averages. And that's the reason why, because the moving averages escape, for example, it's see that it just escaped 7 days. So that's the reason why it's just became discrete instead of a continuous one. Any other questions regarding the waterfall charts before jumping into the next section? I just used the date instead of date total because I didn't have, because if I wanted to just have the date total, the date total was about those moving averages, but I used the date that has all the data points in every day. So that's the reason why I see it as a continuous line. But in this one, I just used the date total for the moving averages, and you see that it just jumped 7 days for each bar I have here. They are discontinuous. That's the reason why it just jumps. But if you want to just see the exact same thing and go through that, I just put the link for downloading that workbook here. So you can just open it and right away see. And also it just the same thing as what we did, and we have a negative cases here, basically the negative cases, and we just did the same thing, but not for the continuous state that for all the days, but for the moving averages that just skip 7 days or whatever that we have. Any other questions, comments regarding the waterfall chart before jumping into the next section? So in this last section, we are trying to provide more customization into your dashboard. For example, creating some a slider for changing the dates interactively and be able to change that, for example, by dragging and dropping that slider. Creating a slider brings more interactivity for the user to change a variable or field. In this example, we want to just create a slider for changing the date range. And I believe we did that before for when we wanted to create a map, when we created a map and we wanted to create a slider for changing the date, a slice date. But again, we are going to go through that here and drag and drop the date into the filter. And it just asks you how you want to just filter. So you see that you just click on the range of dates. And here you have the range of the dates that you can just use it for creating that as slider, and click on apply. Okay. But there are some other options. For example, relative, the range of the date, that's the one that we want to use for a range that I'm going to create here. If I want to just, because the range of the date would be a slider which is in the both side. The user could just change it in the both side, something like this. But if I want to just block one end, I can choose the starting date, end date, or all dates, which don't want to do that, but I can just block one end of my slider, and the user would be able only to slide from this direction, from the beginning to the end. But it's not possible to just change the one here. But it's up to you want to just how you want to customize your visualization, you can just create that, and then after that, show the filter. And then you should be able to interactively filter your data or have a slider that just filter your data interactively. We had the same thing for the last week for the map, but we just did it again for a continuous or the line chart that we had here. We had the same thing basically here. You just put data slider and you are able to slide your data. The next thing, in order to have a more customized dashboard. So let's see if I just create a dashboard and I put some of my visualization here. Let's see, I want to just put this visualization. And then I'm able to create a navigation button. If I just drag and drop a navigation button here, if I click on that, it would just navigate to some other visualization that you have. For example, here I just put the visualization of my donut chart here, but I'm going to navigate the user to, for example, any other visualization or the sheets or even some other dashboards or the stories that I have. So that's the reason, that's where you can just direct this navigation button to which visualization or sheet that you want to have. There are something that you can just put some title, for example, let's say I would just put the waterfall here. You can just change the font to whatever you want, change the border, change the background of this one. And okay. Yeah, that's easy. You can just, I'm going to remove that. Here from the objects, I'm going to drag and drop the navigation here. Yes, you drag and drop from the objects. And then if you just double click on that, here you are able to choose where you want to navigate. And then, for example, put a name for your button here and then click on OK. And that would just give the user ability to navigate when you publish your data, when you publish your dashboard, the user would be able to navigate through different visualization by using these navigation buttons. Similar to what we have here, if this dashboard is going to load here.
On my sheet, it doesn't appear the object. So is there a way for me to make it appear, to find it?
Did you create a dashboard? It should be in the dashboard.
Oh, okay.
Yeah, it's a dashboard.
Okay, thank you.
Yeah, I'm not sure. Maybe something is wrong with my Tableau public server, but I'm going to go into the next one when I have this. So that's another example. And here you have this visualization, this dashboard embedded in this website, and you have these navigation buttons, and you can just, for example, navigate to different visualization if you click on them. And in order to go back to the first page, there is a undo here. You can just go to the back and then, for example, use other ones here. So that's the one example of a dashboard that is incorporated here and have some navigation button to navigate you through different visualization. So you just put maybe one visualization and the user is able to see other visualization if clicks on those buttons for you. And another example of aggregating of some of this visualization together to create a story. And you have this combination of some of this dashboard that I created for different ones that you can just click on this story and be able to see those visualization and be able to interact with them. This website, just embedded in this website. The sheet is already here, the sheets, but You don't have to add any sheet. You can just have a single navigation button. And if you double click on the navigation button, you can just see the option to navigate to, which just gives you a way to navigate to any of your visualization. But if you're asking that, am I forced to just put this donut chart here? No, but it's up to you. For example, if I just remove all of these things here, still my navigation button is going to work. Just navigate to the sheet 7. It doesn't care about those uh, donut chart that I created. So you can have a single navigation button also. Any other question before jumping to the last section, which is about just homework? And after that, any other question that you might have? So the last section is just the homework that, again, with the same data that we had in the 3 previous weeks for that whole world COVID-19 data set extracted from that link. But if you have already that link and the data, you don't need to download it again. And you can just practice on creating the advanced table calculation, calculating the daily new cases, extracted from the total cases, and visualize its moving averages of the newly calculated fields for the new cases. And also create a motion chart that shows the moving averages of the total cases across different continents grouped. And finally, just create an animation or GIF that you can just send me that GIF or animation that you created. And also create a donut chart to visualize the total cases across different continents. And we should be able to create that donut charts. We did that for different counties here, but in this data set, you have some information about different continents. Or also create a slider for different slicing interactively, changing the date range. And then at the end, create a dashboard. If you are able to publish that dashboard in Tableau Public, you can just send me the link of your dashboard, final dashboard. But if that's not possible for you, you can just send me the workbook that you created at the end that has all of this visualization and the dashboard, and that would be fine. So you don't need to just necessarily publish your dashboard somewhere. You can just send me the file of your workbook, and that would be enough. Any other question? Any other comment? Thank you for your participation. And with that, we would just end the Tableau advanced workshop session. I would just wait a couple of more minutes in case if you have any question, but feel free, if you don't have any question, feel free to leave. Thank you. Thank you for your participation.
Hello.
Hi.
Yeah, the last homework, I tried to do some stuffs there, but my forecast was not working. Can you try?
I believe just you send me the question, so I will just look into it and we'll get back to you as soon as possible. Yeah.
I can send you the question.
I'm not sure. Did you send me the question? If not, just please send me the question. I will look into it.
Okay, fine.
Okay. Thank you.
Okay, thank you.
Any other question?